This is Extrema and the first derivative test. Well, let's take a look at our first problem here. And there it goes. We got f of x is equal to x squared plus 6x plus 5. And the instructions say find all relative extrema. Now, what we mean by extrema, extrema refers to extreme values. Now, relative means to what's around it. So like right here, we got a high point relative to what's around it. It's actually where it changes from increasing, decreasing, or decreasing to increasing. So again, this is a max relative to what's around it. Now this is relative max. It's not the highest point. Obviously this goes up forever, so this goes higher. Down here, this reaches a low point. And this is not the lowest point of our graph, because this keeps going down forever, so there's obviously some points lower than that. But this is a low point relative to what's around it. So let's take a look at how to find relative extrema. Extrema is a term that applies to mins and maxes. Our first step is to find a derivative. So on this one, f prime, we take the power, put it out in front, lower it by 1. So we got 2x plus 6. Our second step, set the derivative equal to 0 and solve. So I'll set to 2x plus 6 equal to 0. We're going to see we're going to do something a little bit different with fractions. And I'll take the 6 over, it becomes a negative 6, divide both sides by 2. And you get x is equal to negative 3. And this is your critical value, critical number. Different books call it by different items. Now using your critical values, I'll put an S there because you can have more than one sometimes. Using the critical values, build a table of intervals. Pick test cases. Plug into the derivative. And simplify. And we're looking specifically for the sign. If it's positive, then that means your graph is increasing. If its sign is negative, that means your graph is decreasing. Okay, so we got x is equal to negative 3, which is right here. So build a table of intervals. Clear over here is positive infinity. Clear over here is negative infinity. Now we want to pick test cases. I want to choose a value between negative infinity and negative 3. It doesn't matter what you pick. I'll pick negative 4. And over here we want to pick a value between negative 3 and infinity. I'll choose 0. Now we want to plug that into our derivative. So we're going to plug that into, what do we got here? F prime. And what is f prime? F prime is 2x plus 6. So we're going to plug that into our derivative. So the negative 4 I'll put in for the x. So we got 2 times negative 4 plus 6. Now all we really care here is what our sign is. We don't actually care what the value is. Well, 2 times negative 4 is negative 8. And negative 8 plus 6 is negative 2. Well, this is negative, so this is decreasing. Right there. Now here I plug 0 in for x. So I got 2 times 0 plus 6, which is 0 plus 6, which is 6. And I won't find this value on every one, because again, all we care about is what the sign is. Well, 6 is positive, so it's increasing. Okay. Now, we already set up above that our relative extrema, relative mins, relative maxes, is where it changes from increasing to decreasing. So assuming the graph exists at negative 3, which it does in this case, see how this is decreasing and then it changes over to increasing. So this right here is going to be a relative min. Well, so we got relative min at x equals negative 3. Our step 4 plug in this x value into the original function to find y. So to find y. If I go up here, my original function was f of x is equal to x squared plus 6x plus 5. So I plug it in there. Now remember, f of x is the same as y. So we got y is equal to x squared plus 6x plus 5. And we said there's a relative min at negative 3. So we want to plug negative 3 in for the x. So negative 3 squared plus 6 times negative 3 plus 5. Well, negative 3 squared is 9. 6 times negative 3 is negative 18 plus 5, which gives us negative 9 plus 5, which gives us negative 4. So we got a relative min at, let's see, what did I say? Negative 3 and negative 4. Now these are very easy to actually check to see if it looks like you got it right. If you just go graph it, see what it looks like. Now you may not know the right way to find the relative min, relative max, but definitely by looking at the graph you can determine if what you got is reasonable. So let me go to y equals. Got to fix my calculator from stats. Okay, so what you're going to do is you're going to go to y equals, and we want to put in x squared plus 6x plus 5, and then graph it. Well, it looks like it's decreasing, decreasing, changes here to increasing, and then it's increasing. So this looks like a relative min here. Looks like what, maybe negative 3, negative 2 or something like that? I don't know. See what we've got down here. Negative 3, negative 4. Oops. Don't know what that happened there. Negative 3, negative 4. Yeah, that does look about right if I look over these tick marks. So that our answer is reasonable. Now let me save that. Extrema and the first derivative test. Oops. There we go. BC Extrema and first derivative test. Page 01. Let's look at our next problem. Okay, so we've got f of x is equal to 1/5 x to the 5th minus 16x. And same instructions, we want to find extrema. So first step, find derivative. Take a power, put it out in front, So we got 1/5 times 5x to the fourth, lower it by 1, minus 16, which gives us x to the fourth minus 16. Well, step 2, set that equal to 0. So we got x to the fourth minus 16 equals 0. And factor this. Now, this is the difference of two squares. So this becomes x squared plus 4 times x squared minus 4. Now I can factor the x squared minus 4 again. That's the difference of two squares again. So this becomes x squared plus 4 times x plus 2 times x minus 2. And that's as much as we can factor it. So we set each factor equal to 0. I'll set the x squared plus 4 equal to 0, the x plus 2 equal to 0, and the x minus 2 equal to 0. Now the x squared plus 4 is the square root property. So I'll get the squared by itself. I'll take the 4 over, becomes a negative 4. Square root property says we drop off our squared, we put a plus or minus square root around the other side. Now 2 times 2 gives you 4, and a negative inside of a square root gives you I. Well, whenever we come up with i's, we don't want to use those, so we cross that part out. Here I'll take the 2 over, it becomes a negative 2. Here I take negative 2 over, it becomes a positive 2. So those are my critical values. Well, let's build a table of intervals. So we got negative 2, and we got positive 2. And this is infinity, and this over here is negative infinity. Now we want to pick test cases. So I want to choose a value between negative infinity and negative 2, like negative 3. I want to choose a value between negative 2 and 2, like 0. And then a value between 2 and positive infinity, like, oops, not 1, 3. Okay, then we want to plug them into our derivative. So plug into, I'm assuming it's f prime, instead of y versus y prime. And let's see what we have. Come up here, we got x to the fourth minus 16 as our derivative. So x to the fourth minus 16. And I'll do the same thing here, and do the same thing here. Now all we really care about is what the sign is. We don't have to actually solve it all the way down per se. So if I put negative 3 to the fourth power in, minus 16, anytime you have a negative number to an even power, it becomes positive. And 3 to the fourth. 3 times 3 is 9, times another 3 is 27, times another 3 is 81. 81 minus 16, don't know what it is, but it's positive. So this is increasing. If I put 0 in, I got 0 to the fourth minus 16. 0 to the fourth. 0 to the fourth is 0, minus 16 is negative, so it's decreasing. And over here, plug 3 in. We got 3 to the fourth minus 16. Again, 3 to the fourth is 81. 81 minus 16, don't know what it is, but it's increasing. So here's our graph coming. It's increasing, and then it changes over to decreasing. So assuming this point exists in our original function, which it does since it's polynomial, this is a relative max. Now over here our graph is decreasing and then changes to increasing. So right down here is a relative min. So again, our relative extrema is where it changes from increasing to decreasing, or vice versa. Well, step 4. We said we had our relative max. That's interesting. Not sure why that went up. We had a relative max at x is equal to negative 2. And we had our relative min at x is equal to 2. Step 4 is to plug these values back into your original function. 1/5 x to the fifth. 1/5 x to the fifth. Minus 16x. Okay. We're doing that so we can find y. So I got 1/5 times negative 2 to the 5th power minus 16 times negative 2. Okay, so I got negative 2 to the 5th. That gives me negative 32 over 5. So I got negative 32 over 5. Negative 16 times negative 2 is a positive 32. This is a mixed number. We can take 32 times 5. That gives us 160. 160 minus 32 gives us 128. So we got 128 over 5. Again, use your calculator if you're not very good with fractions. I'm doing it just to double check myself. I'm going to do a second mode to exit out our graph mode. Now I'm going to put in 1/5 beginning parentheses. I think it was negative 2, wasn't it? Negative 2 to the 5th. So closing parentheses, caret 5 minus 16 beginning parentheses, negative 2, closing parentheses, enter. And then I do math, enter, enter to change it to a fraction form. So we got 128 over 5. So my math was correct. And our relative max is at negative 2 and 128 over 5. Let's do our relative min. Again, we're going to plug that back into our original function to find out our y value. So we've got 1/5 times 2 to the 5th minus 16 times 2. That gives us 32 over 5 minus 32. Negative 32 over 5 is negative 160 plus 32 gives us a negative 128 over 5. So this is going to be a relative min of 2 negative 128 over 5. And those are our answers to that problem. Let's save that one. And let's go to our next problem. We've got f of x is equal to 3x to the 4th minus 20x to the 3rd minus 54x squared plus 540x minus 12. Same instructions, find all relative extrema. So go through our steps. First step is to find our derivative. That gives us 12x to the 3rd minus 60x squared minus 108x plus 540. Step 2, set this equal to 0. And solve it. Now these numbers here are kind of huge, but I notice they're all divisible by at least 2. So if I divide everything by 2, this becomes 6x to the 3rd minus 30x squared minus 54x plus 270. Now after I do that, I notice that it looks like all these are divisible by 6. So I can divide everything by 6. So that gives us x to the 3rd minus 5x squared minus 9x plus 45. Now you can do this because you got an equation. You got 0 on one side. So you can divide everything by a number. Now after we've done that, we can use factor by grouping. 4 more terms. I'll group the first two together. The GCF of the first two terms is x squared. So I'll factor that out. And that leaves us x minus 5. For the second two terms, the second group, last two terms, they have a negative 9 in common. And that leaves us x minus 5. Now they both have an x minus 5, so I can factor that out, and that leaves us x squared minus 9. And now it's the difference of two squares. Two terms of minusing it. The x squared minus 9 becomes x plus 3 times x minus 3 equal to 0. Well, zero factor property from college algebra. You get 0 on one side, you factor the other side, you set each factor equals 0. So I'm going to set x minus 5 equal to 0, x plus 3 equals 0, and x minus 3 equals 0. So we get 5, we get negative 3, and we get positive 3. And these are our critical values. Well, let's build our table of intervals. Step 3. Let's see, we got negative 3. We got 3. And we got 5. Over here we got positive infinity. And over here we have negative infinity. Now we want to pick our test cases. So I want to choose an x value between negative infinity and negative 3, like negative 4. I want to choose one between negative 3 and 3, which is like 0. Something between 3 and 5, 4 would be a good one. And something greater than 5, like 6. And we want to plug these into our first derivative. So if I scroll up, our first derivative is this right here. Now this might be kind of hard to work with. What you can do is if you have set it equal to 0 and you have factored everything, you can plug it in right here. Doesn't matter which one you do, you'll get the same answer. So let's plug it into there. So we got x minus 5, then x plus 3, and then x minus 3. Now I'll do the same thing on all these. X minus 5, x plus 3, x minus 3, and x minus 5, x plus 3, and x minus 3, and x minus 5, x plus 3, and x minus 3. Now let's plug these in. We got negative 4, negative 5. We got negative 4 plus 3. And we got negative 4 minus 3. Now we could care less what this is equal to. We'll care what sign is. Well, negative 4, negative 5 is negative. Negative 4 plus 3 is negative. And negative 4, negative 3 is negative. Negative times a negative is positive, times another negative is negative, so this is decreasing. Now if I put 0 in here, I got 0 minus 5, 0 plus 3, and 0 minus 3. Well, this is negative. This one will be positive. And this last one will be negative. Negative times positive is negative, times another negative is positive. So it's now increasing. If I put 4 in here, I got 4 minus 5, 4 plus 3, and 4 minus 3. 4 minus 5 is negative. 4 plus 3 is positive. 4 minus 3 is positive. Negative times a positive is negative, times another positive is negative. So this is decreasing. Let's scroll down a little bit here. There we go. Okay, so if I put 6 in, I got 6 minus 5, I got 6 plus 3, and I got 6 minus 3. 6 minus 5 is positive. 6 plus 3 is positive. 6 minus 3 is positive. Positive times positive times positive is positive, so it's increasing. Okay, so my graph is decreasing here, and then changes to increasing, so this is going to be a relative min. Here it's increasing, and then changes to decreasing, so this is going to be a relative max. Here it's decreasing and changes to increasing, so this is going to be a relative min. Again, our relative extrema is where it changes from increasing to decreasing or vice versa, assuming that our graph exists at that critical value. And the only time it won't exist at critical value is when you're talking about radicals, and it may not fit in the domain of those, or you're talking about fractions. Okay, step 4. Now that we found those, we're going to plug those back into our original function. So I'll plug in x equals -3, x is equal to 3, and x is equal to 5. Keep in mind this one is a min, this one is a max, and this one is a min. Now I don't want to work that hard, so I'm going to go back to my original function here, and I'm going to plug that in my calculator. Now you can do it by hand if you want. Go to y equals, press clear, and I got 3x to the 4th, so 3x caret 4, minus 20x to the 3rd, so minus 20x caret 3, minus 54x squared, so minus 54x squared, plus 540x, minus 12. Now, I'm going to go to my table set, so I'm going to do a second window. And you see where it says independent? We want that to say ask. So if yours doesn't say ask, down arrow to that line, right arrow, put your flasher cursor on the ask, and press enter one time. And once you got that set, do a second mode to exit out. Okay, now we're going to go into table mode. So we'll do second graph to go into table mode. And I have values here, and that's weird. Let me go here, and I'm going to clear out y2. So I'll go down there and press clear. Not that it matters. Now do second graph. I had 0 on y2, that's why it was zeros in all those. Now I have values here. You may or may not have them. I'm going to press delete to clean out those old ones. And so we got that in there now. So plug in -3 and push enter. So at this one, I'm going to have a relative min at -3, comma, -1335. Now this one, I'm going to have a relative max at 3. I'm going to come over here, do 3, enter. 3,825. Now these are pretty big numbers, because I made these problems up, so some of them do come out that way. And this one will be 5, enter, which is 713. And those are our relative extrema for that problem. So let me save that. And let's look at our next problem. So find all the relative extrema of this. So I got f of x is equal to 5x minus 60 x to the 1/3 power. Now x to the 1/3 is the same as a cube root, and for a cube root the domain is -infinity, +infinity, so we don't need to worry about anything. But our first step, find our derivative. Well, 5x becomes 5 minus 60. Take our power, put it out in front, lower it by 1. 1/3 minus 1 gives us -2/3. Now 60 times 1/3 gives us 20. And I'm going to take that x to the -2/3 and put it down in the denominator, because we don't want any negative exponents. Now always on these problems, you want to get a single fraction. If you got one fraction and something else, you need to merge them together. So I'll put this over 1. Then our common denominator, you just multiply these two denominators together. And our common denominator would be x to the 2/3. Now that one already has that denominator, so we're fine. This one, the first fraction, we multiply the bottom part by x to the 2/3. We have to multiply the top part by x to the 2/3. So we get an f prime of x is equal to 5x to the 2/3 minus 20 over x to the 2/3. Okay, so we got our single fraction. Now remember, I said that we're going to find the critical values a little bit different when you got a fraction. To find our critical values, you're going to set your top part equal to 0. So I'll take 5x to the 2/3 minus 20 equal to 0. And we'll set our denominator equal to 0. Like that. Now in this first one, we got x to a power. We want to get the x to a power by itself. So I'll take negative 20 to the right side, becomes a positive 20. I'm going to divide both sides by 5. And we got x to the 2/3 is equal to 4. Now, if you got x to the 2/3, you want to raise both sides to a reciprocal of that. So we've got x to the 2/3. We're going to take both sides to the 3/2 power. Now, if your number up on top is even, see the 2 here is even? That means you put a plus or minus on the other side. If it's odd, like if I had a 3/5 for the exponent, then we don't put a plus or minus. But in this case, we do. So as 2's cancel, as 3's cancel, we got x. Excuse me. And we got a property from intermediate algebra that says if you have a number to a fractional power, you can take the numerator and put it on the outside of the parentheses. So we got 4 to the 1/2. 4 to the 1/2 to the 3rd power. I'm going to go up here. Well, 4 to the 1/2, that's the same as the square root of 4. The 3rd power. And square root of 4 is 2, so we got 2 to the 3rd, which then gives us plus or minus 8. And those are critical values. Now our other one up here, the x to 2/3 equals 0. Whenever you have x to a power equal to a number, or equal to 0, I mean, you can just drop the power. So this is just x is equal to 0. And that's also another critical value. Okay. Well, now let's come down here, build our table of intervals. So I'm going to have x equals -8. I'll have x is equal to 0, and I'll have x is equal to positive 8. Those are our 3 critical values. Clear over here is positive infinity. And clear over here is negative infinity. Now we want to pick test cases. We want to pick a value between negative infinity and negative 8, like negative 9. Pick something between negative 8 and 0, like negative 1. Pick something between 0 and 8, like 1. And something between 8 and infinity, like 9. And we want to plug them into our derivative. So let me find out what our derivative is. I guess it's this 5x to 2/3 minus 20. Let me jot that down on a piece of paper so I don't have to keep going back up and down. 5x to the 2/3 minus 20 over x to the 2/3. Oops. Okay, so I want to plug that in, the test cases, into our derivative. 5x to the 2/3 minus 20 over x to the 2/3. And we're going to plug in all four of these. Now let's save ourselves some time. Now, if you're not very good with the calculator, you might just want to do it by hand. You're probably going to find it easier than to fiddle around and screw up your parentheses and everything. Now, we're going to enter this in by putting parentheses around top, and we'll put parentheses around the bottom. Technically, you don't need them around the bottom, but just to be on the safe side, if you got a fraction, put parentheses around top, parentheses around the bottom. So let's go input this in to our calculator. So press y equals, press clear. I'm going to do a beginning parentheses, 5x, and caret. And then we'll put in 2/3. When I put in 2/3, since it's more than a single number or a single variable, I had to put parentheses around it. So I'll put a beginning parentheses, 2 divided by 3, closing parentheses. Now, if you got one of the newer versions of the T84, when you did the caret, it threw up in exponent mode. And after you put in 2 divided by 3, you just right arrow get out of exponent mode. And minus 20. We'll put a closing parentheses on top of the fraction, then divided by beginning parentheses on the bottom, and we got x to 2/3. So I'll do x caret, and I have to put parentheses around the exponent because there's more than a single number or a single variable. So 2 divided by 3, closing parentheses on 2/3, closing parentheses on the denominator. Okay, so now I'm going to do a second, and then go to my table. Where's the table? Oh, there it is, graph. So second graph. I'm going to press delete a few times to clean out the ones that are there. And let's plug in our test cases. So we got -9. We came up with a positive number, didn't we? Which means this is increasing. Let's put in -1. We came up with a negative number, which means this is decreasing. If we put in +1, negative, so it's decreasing still. And then if we put in 9, we get a positive number, so this is increasing. Now, you could go through all the algebra to plug it into here and so forth, but graphing calculator is very nice for helping simplify those a little bit. I mean, these problems are challenging enough as is. Now, assuming that our graph exists at these critical values, this right here, it's increasing and then changes to decreasing. So this is going to be our relative max. This one is decreasing and then it's still decreasing, so this is nothing. Now over here, this is decreasing and then changes to increasing, so this is our relative min. Well, step 4. We got x equals -8. We said that's a max. And we also got x is equal to 8. That's a min. Well, I'm going to put my original function into my calculator. So I'm going to go to y equals. Press clear. And my original function, what's that look like? 5x. So 5x minus in 60 x caret. And notice I have more than a single number or a single variable in my exponent, so I put parentheses around it. So I do a beginning parentheses, 1 divided by 3, closing parentheses. And now I'm going to go back to table mode. So I do second graph. Now I'll delete those values because I'm going to use different ones. And we said we have a max of -8. So let me put in -8 and push enter. Then we get 80. So our first answer is relative max at -8, 80. Let me come over here and put 8 in. So I do 8, enter, and we get -80. So relative min at 8 and -80. And those are our two answers. That one was a little bit nasty because it was disguised, but it really was a radical. And anytime you have radicals, they come out a little bit hideous. So let me save this. And we'll look at the next problem. number 5. Got f of x is equal to x minus 1 to the 1/5 power. Let me grab a drink real quick here. Okay. So same instructions, I think. Yeah, find all relative extrema. So our first step is we're going to find our derivative. This is the chain rule. We got parentheses to a power. So to find our derivative, we take our power, put it out in front. What's inside the parentheses remains as is. Lower our power by 1. And then you multiply it times the derivative of what's inside the parentheses, which is x minus 1. Well, actually, let me jump ahead. That gives us 1/5. X minus 1, and 1/5 minus 1 gives us negative 4/5. And the derivative of x minus 1 is just 1, so it drops away. So now, I put 1 here, put 5, and then I put x minus 1 to the positive 4/5. Remember, if you have a negative exponent, you take it the opposite where it's at, and the sign of the exponent changes. Okay, so for our second step, there's nothing on top to set equal to 0, so we'll just set the bottom part equal to 0 in order to find our critical values. Now, if you have 0 on one side and you got parentheses to a power and there's a number in front, all you have to do is take what's inside the parentheses and set it equal to 0. Works out very nice on these. So we get x is equal to 1. Okay. And we want to build our intervals, and maybe I don't get enough room there. Let me try it again down below. So x equals 1 is our critical value. This is our infinity. This is our negative infinity. Now, if I were to put the 1 in here into our derivative for the test case, it causes 0 in the denominator, but that isn't a real big issue. If I plug 1 into my original problem, we get 1 minus 1, which is 0, 0 to the 1/5. That's actually okay. You have to, this has to actually exist in your original function. If this didn't exist, then it definitely can't be a min or max. Okay, so we want to pick test cases. So I'm going to pick a value between negative infinity and 1, like 0. And I want to choose one between 1 and infinity, like 2. And we want to plug this into our derivative. So we got 1 over 5 x minus 1 to the 4/5 power. I'm going to go ahead and just do this by hand. I'm too lazy to type it into the calculator. Now, if I plug this in, 0 minus 1 is negative 1, negative 1 to the 4/5 power. Since we got an even number in the numerator, this is the 4/5 power. Since we got an even number there, this is always going to be positive, which means this is increasing. And if I put 2 in, if I put 2 in here, I get 2 minus 1 to the positive 4/5, which this also gives us a positive number, so this is increasing. Now I notice it's not changing any. It's not changing from increasing to decreasing. So with this one, there is no extrema. There's no mins or maxes. Well, let's look at it and just see what the original graph looks like. If I go to y equals and press clear, I do beginning parentheses x minus 1, closing parentheses caret, and since I have more than a single number or a single variable in my exponent, I had to put parentheses around it. So I put beginning parentheses 1 divided by 5, closing parentheses, and let's push graph. Okay, there it is increasing. Then all of a sudden it's straight up and down at a certain point, and then it's also increasing. So yeah, there's no min or max with that. Let me save that. There we go. Let's look at our next problem. Let me shift a little bit here in my seat. Oh. Okay. Find all relative extreme of the function. We've got f of x is equal to x plus 4 over x. Now I'm going to want to find the derivative of that, and it's really best to be in the form of x to a power. So this is going to become x plus 4x to the negative 1. It's like the first power down here, so I take the x to the first power up on top, and it becomes x to the negative 1. Okay, so then for our first derivative, x becomes 1. Here we take our power, put it out in front, and then lower it by 1. That gives us 1 minus 4 over x squared. And we want to get a common denominator, so I'll put this in fraction form, 1 over 1. Which multiply top and bottom by x squared. And we end up with x squared minus 4 over x squared for a derivative. Okay, so for our critical values, we're going to set top part equal to 0 and the bottom part equal to 0. So I set x squared minus 4 equal to 0, and x squared is equal to 0. Well, this is a square root property. I'll take negative 4 over, it becomes a positive 4. From college algebra, if you have something squared equal to the other side, you can drop the squared, and you put a plus or minus square root around the other side. Now, square root of 4 is 2 times 2. And with square roots, we're looking for a pair of somethings. Here's a pair of 2's. So that comes out as a single 2. Now over here, again, whenever you have x to a power equals 0, you can just drop the power. So we get x is equal to 0. Now, one thing to notice here, the x equals 0. We're going to look at that as our critical value. That goes without saying. But if I were to put 0 back in my original problem, I would have 0 in the denominator. So 0, while it can be a place where increasing and decreasing changes, it cannot be a relative min or relative max. Because again, it causes 0 in the denominator. So let's go do this. So we got x is equal to negative 2, x is equal to 0, and x is equal to positive 2. That's interesting. There, let me try that again. I was moving my mouse while I was trying to draw a straight line. They're counteracting each other. Honest, I'm not drinking. I don't drink anymore. Okay. Now I want to pick test cases. I get high on math. Okay. So we pick a test case between negative infinity and negative 2, which is negative 3. Pick one between negative 2 and 0, like negative 1. And one between 0 and 2, which is 1. And one between 2 and infinity, let's say 3. And we want to plug these into our derivative. Now our derivative is x squared minus 4 over x squared. So x squared minus 4 over x squared. So plug into our first derivative. Okay. Now all we care about is the sign. X squared is always positive, so we don't even need to plug it into the bottom part, because I know that's going to be positive no matter what. So let's plug it in the top part. So we got negative 3 squared minus 4. Negative 3 squared is 9. 9 minus 4 is positive. Positive divided by positive is positive, so this is increasing. If I put negative 1 in, I get negative 1 squared minus 4. Negative 1 squared is 1. 1 minus 4 is negative. Negative divided by positive is negative, so this is decreasing. If I put 1 in, I got 1 squared minus 4, which is negative, which is decreasing. And if I put 3 in, I got 3 squared minus 4. 3 squared is 9. 9 minus 4 is positive. Positive by positive is increasing. So this right here is a relative max because it changes from increasing to decreasing. This one down here is decreasing and then changes to increasing, so this is a relative min. Step 4, we want to plug those into our original function to find out what the y value is. Original function was x plus 4 over x. So let's see what those give us. Okay, if I plug in negative 2 here, I get negative 2 plus 4 divided by negative 2. 4 divided by negative 2 is negative 2. So we get y is equal to negative 4. So this is going to be a relative max at negative 2, negative 4. On this one, I'll plug 2 in. So we got y is equal to 2 plus 4 over 2. 2 and plus 4 divided by 2 is 2, so we get y is equal to 4. So there's going to be a relative min at 2, 4. And those will be your answers. So let me save this. Okay, 6. And let's look at our next problem. We got f of x equals x to the third minus 5x squared plus 6x minus 2. Now it says use a graphing utility to find graphically all relative extrema of the function. So let's take a look at how to do that. We're first going to go plug this in our calculator. So press y equals, press clear. And then we got x to the third. So do x caret 3 minus 5x squared plus 6x minus 2. Now let's first just look at this and see what it looks like. So let's press graph. Graph is increasing, increasing, comes up here, and then it starts decreasing. And then decreases, hit this, and then it starts increasing. So it looks like we have a relative max here and a relative min here. Well, let's take a look at how to find that. Now, for one thing, if your graph is such you can't see it very well, you can do some zooming. So if I press zoom, and Z box is probably the nicest one. If I choose Z box, I'll press enter on it. I'm going to do my up arrow key and my left arrow key, and I want to put this in the upper left hand corner of the box I want to draw, which that's fine right there. So I'll press enter one time. Do not press enter twice. And I'm going to go through my bottom right hand corner. So I'm going to press my down arrow and right arrow, and you'll see a box being drawn. I want to make sure I include the relative mins and relative maxes. That looks good right there. So press enter. Now after you press enter that time, it'll zoom in on just the box you drew. Okay, so now we can see things a little bit better. Okay, this right here looks like a relative max. So let's find that first. We're going to do second trace, and you see we got a maximum, the fourth one. So I'm going to press forward to choose maximum. Now it says left bound, and your cursor might be in a different place than mine, but what we want is we want the cursor on the left hand side of where that max is. So I'm going to press my left arrow key until it's on the left side of where that max is. Now it doesn't have to be clear over there. That's definitely to the left of where my max is. So I'll press enter one time, and that's our left bound. Now then it comes up and asks us for our right bound. So we have to press the right arrow key until the cursor is over on the right hand side of where the max is. Now once we get over there, we press enter, and then it asks for us for the guess. So we press enter one more time, and this will be our maximum. So we got a relative max at 0.78, I don't know, around at 3 decimal places maybe, 0.785, comma, 0.113. Now, if it's possible to change to a fraction form, the way you can do that, not all of them are possible, because some of them are actually radical answers. The way to do that is if you exit out, do a second mode. First notice that this is x equals and this is y equals. So we did second mode to exit out. If I press my X key and then math, enter. If it'll change to a fraction, it would then. To do the y, I have to do my alpha 1 to get y on there, and then I press math, enter. Well, that's no good either. It doesn't change. Well, let's press graph to go back here. So we found our relative max. We want to find our relative min over here. So I'm going to do second trace, and I'll choose minimum, number 3. Now we want to put our cursor to the left of where the min is. Now this is to the left, but it might be a little bit too far from to the left. So I'm going to press my right arrow key to get it closer. And that's probably good enough right there. Then I push enter. Now it asks us for right bound. So I want to press my right arrow key to get it to the right of where the min is, which is right there. Now occasionally your cursor will be off the screen. Like there. You have no clue where it's at. It's just like, whoa, where's my cursor at? If you look down at these values here, it'll tell you where it's located at. See, x equals 4.19, and if you press your left arrow key, you can bring it back in. So that's kind of handy to see where in the world it's at. But anyway, we want it to the right of the min. And then we push enter. And then if you've done a good job with your left bound and right bound, you always do enter on guess. And that would be our relative min. Three decimal places. I got 2.549, comma, negative 2.631. And those will be our answers. Problem with this technique is you don't get exact answers. You get approximations, which if that's all you're looking for, then the graphing calculator is fine for that. Now I hate to save that on one page by itself, but I'm afraid this next problem is a little bit longer than I need the space, what I'm saying. Okay, so let's look at our next problem. Let me grab a drink before I do this too. This is find an absolute extrema. So we got f of x is equal to x squared plus 6x minus 1. And this is from negative 5 to 2. And it says find the absolute extrema of the function on the closed interval. So finding absolute extrema. Now absolute refers to your very highest point and your very lowest point. So it's not relative to what's around it, but it is truly is your highest and lowest. Okay, first step, find the derivative. Okay, so we got f prime of x is equal to 2x plus 6. And I'm going to have to open my window here. got the heat on in the house. It's killing the fat guy. There. Okay, now we're going to set our derivative. If I can write legibly. Set our derivative equal to 0. And solve. So we got 2x plus 6 equal to 0. Take the 6 over, it becomes a negative 6. Divide both sides by 2. And you get x is equal to negative 3. Now remember, these are our critical values. Now I'm going to put a note here. Cross out any critical values not in your interval. So not in the interval. We came up with negative 3. Our interval is from negative 5 to 2. Well, negative 3 is in that range, isn't it, of numbers. So that critical value is okay. Step 3, plug in the critical values and the endpoints into the original function. And simplify. Well, our interval was negative 5 to 2, so we want to plug in negative 5. We want to plug in negative 3, that's our critical value, and then we want to plug in our other interval, which is 2. And we want to plug that back into our original function. Original function is this right here. So we got x squared plus 6x minus 1. So plug negative 5 in. We got y is equal to negative 5 squared plus 6 times negative 5 minus 1. That gives us 25 minus 30 minus 1. 25 minus 30 is negative 5 minus 1, which gives us negative 6. Let's plug in negative 3. So we've got negative 3 squared plus 6 times negative 3 minus 1. That gives us 9 minus 18 minus 1, which gives us negative 9 minus 1, which gives us negative 10. And let's plug in 2. So we've got y is equal to 2 squared plus 6 times 2 minus 1, which gives us 4 plus 12 minus 1, which gives us 16 minus 1, or gives us 15. Now our absolute min is the lowest y value. So on this particular problem, I got negative 6, negative 10, and 15. Our lowest value is negative 10. So our absolute min is the negative 3, negative 10. Now our absolute max is the largest, the highest y value. So for this problem, our absolute max, the highest y value is the 15, so our absolute max is 215. And those will be our answers. Let me save that and we'll look at another problem. Let me shift myself in my seat here a little bit. Okay. Number 9. Same instructions, find the absolute extrema. So we've got f of x is equal to x to the third minus 27x and between 0 and 5. Well, remember, we need to find our derivative, which would be 3x squared minus 27. Second step, set that equal to 0 and solve. That'll give us our critical values. Well, here I'm going to get the x squared by itself, so I'm going to take negative 27 on the right side, becomes a positive 27. Divide both sides by 3, and 27 divided by 3 gives me 9. Now the square root property. Drop your squared, and you put a plus or minus square root around the other side. 3 times 3 gives us 9, so we get x is equal to plus or minus 3. So we got x is equal to negative 3, and x is equal to positive 3. Now look at our interval. Our interval is from 0 to 5. Negative 3 isn't in that interval, is it? So we want to cross that one out. We're not going to use that one. Okay, so step 3, we're going to plug in our different x values, our endpoints, our small part of our interval, the 0, the critical value, which is 3, and then the 5. And we want to plug these into our original function. So we've got y is equal x to the third minus 27x. Now, again, I'm going to show you a very nice way to do this on your calculator. Save yourself some time. Whenever you're evaluating on your calculator, you can go enter in x to the third minus 27x on y equals. Now, I'm zoomed out from this previous problem here. Not that it matters for what we're doing here, but I'm going to press zoom and choose Z standard and set it back to our standard viewing window. So zoom and then 6. So I go to y equals, press clear, and I'm going to put in x to the third minus 27x. So I do x caret 3 minus 27x. Right there. And I'm going to go do second graph to go in table mode. I'll press delete a couple times to clear out those old numbers. And we're putting in 0, 3, and 5. So 0, enter, 3, enter, 5, enter. So that gives us 0 there. This one gives us negative 54. And 5 gives us negative 10. Very fast way to do that. If you want to spend a huge amount of time on the elementary algebra items like that, that's fine. But probably better if you focus more on the calculus and let the calculator do some of that. Okay, absolute min. Absolute min is the smallest y value, which would be, looks like negative 54. So absolute min would be 3, negative 54. Now our absolute max is the largest y value, which these are both negatives, so this would be 0. So our absolute max is at 0, 0. And that's our answer. Let's save that. And let's look at our next problem. Find the absolute extrema. So I got f of x is equal to x squared over x squared minus 5 from negative 2 to 4. Okay. Well, let's find our derivative. This is absolute extrema, so again, that's our first step. Well, this would be the quotient rule. This is P and this is Q. P prime would equal 2x and Q prime would equal 2x. Our formula is P prime Q minus P Q prime over Q squared. So our derivative is going to be P prime, which is 2x, times Q, which is x squared minus 5, minus P, which is x squared, times Q prime, which is 2x, over Q squared, which is x squared minus 5 squared. Now let me double check myself here. P prime, which is 2x, times q, which is x squared minus 5, minus p, which is x squared, times q prime, which is 2x. Okay, that looks good. Now to, in preparation, actually, I'm lying to you. Take that off. Simplify it before we go on. They both have a 2x up on top, so I can factor that out in front. And that leaves me x squared minus 5 minus x squared. Well, then the x squared minus x squareds cancel inside the brackets. So we got 2x times negative 5, which gives us negative 10x over x squared minus 5 squared. Okay, let's find our critical values now. So I'm going to set the top part equal to 0. This is step 2. So set negative 10x equals 0. That would give us x equals 0. And we'll set the bottom part equal to 0. So we got x squared minus 5 squared equal to 0. Now remember, if you have parentheses to a power equal to 0, you can drop the power. So we got x squared minus 5 equal to 0. Take the negative 5 to the right side, becomes a positive 5. Drop our squared and put a plus or minus square root around the other side. So we got 0 and plus or minus square root of 5. Now square root of 5, let's see what in the world that is. I think it's 2 point something. So I'll do a second mode to exit out. And I'll do second x squared, and I'll put in 5. 2.23, so forth. Well, this means we got x is equal to plus 2.23, and x is equal to negative 2.23. Well, look at our interval here. It goes from negative 2 to 4. This negative 2.23, so many in the more decimal places here, we want to cross that one out. That's not in our interval. Okay, so step 3. We're going to test our smallest value, I guess, is the beginning, the negative 2. We also want to check the next one, which would be 0. The next one, which would be square root of 5. And then the next one, which would be 4. So let's plug that into our original function, which is, what is it? X squared over x squared minus 5. Now this one's pretty easy to type in. I'm not going to put it in my calculator. You could if you wanted to, though. Key would be to put parentheses around the denominator. Anytime you have more than a single variable or a single number on top or bottom, you have to put parentheses around it. Okay. So here I got negative 2 squared over negative 2 squared minus 5. That gives us 4 over 4 minus 5. Negative 2 squared is 4, which gives me 4 over negative 1, which gives me negative 4. If I put 0 in, I got 0 squared over 0 squared minus 5, which would give me 0. Because 0 squared is 0, and 0 divided by anything is 0. If I put in square root of 5, so we got square root of 5 squared over square root of 5 squared minus 5. We got 5 up here. Down here we got 5 minus 5. This is undefined, isn't it? Can't have a min or max at an undefined value. And if I look back up here, if I were to put square root of 5 up here, it doesn't work, period. So that one we can cross off. So let's plug in 4. So I got y is equal to 4 squared over 4 squared minus 5, which is 16 over 16 minus 5, 16 over 11. Okay. Well, now we're ready to tell what our absolute min and absolute max is. So absolute min is our smallest y value. 16 elevenths, 0, negative 4. Negative 4 obviously is 1. So we have negative 2, negative 4. Our absolute max is our largest y value, which looks like 16/11ths. So we'd have 4 and 16/11ths. Unfortunately, in the table mode, you can't get 16/11ths. It just gives you a decimal approximation. Sometimes it's you have to do it by hand, unless you really are looking for a decimal approximation. There we go. I was wondering when it was going to blow up. I was having pretty good luck with my little tablet. And let's look at the next problem. Getting close to the end. F of x is equal to 7x minus 1 to the 2/3 power between -8 and 4. Same instructions, find the absolute extrema. This is the chain rule. We've got parentheses to a power. So our first derivative, take a power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1. And then you multiply it times the derivative of what's inside the parentheses, which is 7x minus 1. So that gives us 2/3, 7x minus 1. 2/3 minus 1 gives us -1/3. And derivative of 7x minus 1 is 7. Okay, so up on top we're going to have a 2, and the 7 goes up there, 3 goes down here. Now this negative exponent we're going to take down to the denominator. So this becomes 7x minus 1 to the positive 1/3. So we get 14 over 3 times 7x minus 1 to the positive 1/3. Well, now we're going to find our critical values. There's no use setting the 14 equal to 0, so we'll set the bottom part equal to 0. So 3 times 7x minus 1 to the 1/3 power equal to 0. Again, if you have parentheses and then to a power and a number out in front, you can just set what's inside the parentheses equal to 0. So we've got 7x minus 1 equal to 0, 7x is equal to 1, or x is equal to 1/7. Now this is our critical value, and it's in our interval here from -8 to 4, so we can use that. So, -8 and 4. And 1/7. We want to plug these into our original function. So we got y is equal to 7x minus 1 to the 2/3. And here we got 7x minus 1 to the 2/3. And here we got 7x minus 1 to the 2/3. This is probably not going to come out nice, because I made these numbers up. So we got 7 times -8 minus 1 to 2/3. That gives us negative 56. Mine's shutting down. It's too late. Yeah, -56, -1, -57 to the 2/3. If I plug in the value here, the 1/7, I got 7 times 1/7 minus 1 to the 2/3. 7 times 1/7, the 7's cancel, and we got 1 minus 1, which is 0. 0 to 2/3 is 0. And this one, if I plug 4 in there, I got 7 times 4 minus 1 to the 2/3. That gives me 28 minus 1 is 27 to the 2/3. This one can actually simplify. If I went down further with this, 27 to the 2/3, you can take your numerator, put it on the outside like that, and this becomes the cube root of 27. And the cube root of 27, 3 times 3 times 3, which gives me 3 squared, which gives me 9. Now, actually, what benefits us the most, though, is the original form here. And I don't think this breaks down. 57. Let me double check my calculator. I don't think that's anything. It can't be 7. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. Never mind. Nice to even look at it. Okay. Now we could simplify it a little bit, but since we got a second power on here, that negative is just going to disappear. So this is like 57 to the 2/3 power. Let me actually show the steps. So if I put this inside of a radical, this is similar to what we did here. The negative can come out, and then when we square it, it becomes positive. So that's cube root of 57 over 2, which is 57 to the 2/3 power. Well, looking at this, my absolute min is obviously the 0. And what was my x value on that? X value is 1/7. So we got 1/7. Our absolute max. Here we got 27 to the 2/3. Here we got 57 to the 2/3. I'm guessing 57 to the 2/3 is more, but let me plug in my calculator just to make sure. Brain starts shutting down at night, even though I did take a nap when I got home. Just thought I'd share. That's 14, and the other one was 9, so this is obviously more. So our absolute max would be, what's the x value here? -8. So this would be -8 and 57 to the 2/3. Now originally when I started this problem, I was thinking that this negative here meant this was smaller. But when we plug it into our radical form, we see it becomes positive, so it actually changes around. So that's interesting, if you're into math. Okay, let me save that. And then we'll look at our last problem. Been going quite a while, but I'd rather you have a bunch of good examples. You can fast forward through these and watch them, and if you need them, they're there. Okay. One last one. We got f of x is equal to x squared plus 2 over x. And it says find the absolute extrema. So same instructions, but now we have a beginning, we have a 0, but then it goes to infinity. That I couldn't figure out how to do infinity on the PowerPoint. So we only got one endpoint, the beginning. Well, I'm going to rewrite this first as x squared plus 2x to -1. Because again, our derivative works out better if it's in form of x to a power. So this becomes 2x, take the power, put out in front, lower it by 1. So this is 2x over 1 minus 2 over x squared. Get a common denominator, multiply top and bottom by x squared, and you get 2x to the 3rd over x squared minus 2 over x squared, which gives us 2x to the 3rd minus 2 over x squared. Now for a critical value, we're going to set top part equal to 0, and we'll set our bottom part equal to 0. Well, this one gives us x equals 0. That doesn't benefit us a whole lot, because we were going to use 0 anyway, because that's our beginning of our interval. Over here, I'll take -2 to the right side, becomes a +2. Divide both sides by 2, and we get x to the 3rd is equal to 1. Now x to the 3rd is like x to the 3 over 1 power. And we can take both sides to a reciprocal of that. So we'll take both sides of the 1/3 power. Those 3's cancel, those x's cancel, and 1 to any power is 1. So we got two values to check, 0 and 1. And we're going to plug them into our original function. So we got y is equal to x squared plus 2 over x. So I got 0 squared plus 2 over 0. Oh, that's not good. That implies that 0 can't be included. So that one won't work. So let's do the other one. So plug in 1. So we got 1 squared plus 2 over 1, which gives us 3. Now it makes me wonder, what this graph even looks like then. So let's go take a look at it because I'm curious. X squared plus 2 over x. And then graph. So starting at 0 and going forever here, I see that doesn't exist at 0. It just keeps getting closer and closer. Looks like it's going up forever, doesn't it? Since we can't use 0, then that's not an absolute max up there. But it does have an absolute min right down here. So this right here is going to be an absolute min at 1, 3. Now this is a curious one. Since we only had the one value, without looking at the graph, I wasn't sure if this was an absolute min or absolute max. So that's interesting. We could use the fact that we found a derivative to get that x is equal to 1. And then find increasing and decreasing to help us figure out which one it is. But graph is probably the easiest way. So anyway, that's our answer. So let me save that. I actually made that problem up, so that's interesting it came out the way it did. Sometimes they come out quite interesting when you make them up. And let me stop the recorders now. And this is Extrema and a first derivative test. What is... I just want to copy that. There. Oh, there it is. I should actually read.